harsh freezing winter on the Great Plains or in the subarctic was not an enemy, but merely a circumstance. Think of the biting wind, temperatures dropping to tens of degrees below zero, and snow covering the ground for months. For the indigenous peoples of North America, this was an annual reality they faced without modern heating systems, wood storage, or down comforters as we know them. It was engineering born of necessity, honed by millennia of observation. Every action, from the location of the camp to the way the sleeping area was arranged, had one goal: to preserve precious heat. We will immerse ourselves in a world where survival depended not on the power of fire, but on the power of the mind. Watch the video to the end to learn how entire communities thrived in the icy wilderness using snow as insulation, and why their homes were warmer than you can imagine. What I am about to show you has been kept secret for generations. We are used to thinking that a big, roaring fire is necessary for warmth in winter. This idea is deeply ingrained in our minds. The bigger the flame, the more warmth and comfort. However, for the indigenous peoples of North America, this approach would be not only wasteful, but also dangerous. Their philosophy of survival was based on efficiency, not excess. A large fire consumed a huge amount of fuel, which was difficult to obtain in deep snow. Every dry branch was a valuable resource, and it was impractical to waste it on creating a short-lived but hot flame. Moreover, a large fire created a sharp contrast in temperatures. Standing next to it, one side of the body would overheat, while the other, exposed to the cold wind, would remain vulnerable. Such an imbalance was uncomfortable and could lead to health problems. The real art was in maintaining a small, controlled fire. A small hearth, no larger than a dinner plate, could provide enough heat to cook food and warm a small space. It required a minimum of fuel but burned steadily and for a long time. This approach required a completely different way of thinking. Heat was not something that could be taken in excess, but something that had to be carefully preserved and concentrated. The focus shifted from producing heat to retaining it. Therefore, dwellings were designed not as places where heat had to be pumped in, but as thermoses that would preserve what was already there. This applied to the heat produced by the fire itself, and equally important, the heat generated by human bodies. Psychologically, this also changed perceptions. Comfort did not mean a hot room, but the absence of cold. Coziness was created not by an excess of heat, but by having enough of it in the right place at the right time. The indigenous people understood that the real enemy was not the cold itself, but the wind. It was the wind that blew precious heat out of clothing and dwellings. Therefore, the first and foremost task was to stop the movement of air. This minimal fire strategy was the first and perhaps most important secret to survival. It allowed them to stretch their scarce resources throughout the long winter and taught them to value not the brightness of the flame, but its efficiency.
See how the wind moves around these logs? We place the kindling here to catch that draft.
I understand now. We must respect the fire's breath.
Do you agree with this? Please tell us what you think about this. Every opinion is valuable, and don't forget to subscribe to our channel so you don't miss our research. Are you ready to learn the truth about the most famous dwelling of the plains? At first glance, the tepee of the Great Plains tribes, such as the Lakota or Cheyenne, seems like a simple conical tent. However, this simplicity is deceptive. The tepee is one of the most sophisticated and aerodynamically efficient mobile dwellings ever created by humans, especially for harsh winter conditions. Its ingenuity began with the foundation. The winter tepee was not simply set up on frozen ground. A mound of earth or snow was often piled around the base, completely blocking any drafts coming from below. This created an airtight seal at the base. A key element of survival in the cold was the inner lining, known as the ozone. It was essentially a second wall inside the tepee, made of treated hides or thick fabric. It ran along the entire inner perimeter, rising to a height of 1.5 to 2 meters. The ozone served several critical functions. First, it created an air gap between itself and the outer covering. This layer of still air served as an excellent insulator, similar to the principle of modern double glazing in windows. Second, this inner wall blocked cold air that could seep through the seams of the outer covering. It also caught condensation droplets that could form on the inside of the cold outer layer, preventing them from dripping onto the inhabitants. But the most ingenious part of the ozon was its work with air currents. It directed the cold air that still penetrated from below upward into the space between the two layers. There, this air mixed with a warm air from the hearth and escaped through the smoke vents at the top. This way, there were no icy drafts on the floor inside the living space. The people sitting inside were protected from the direct flow of cold air. This allowed them to sit comfortably on the floor, even when a blizzard was raging outside. But what if I told you that it was possible to build a dwelling where the heat from a single hearth could warm 100 people at once?
And so the Great Bear wandered back into the woods, never to be seen again.
A fine tale, old one.
Yeah.
Are you ready to learn the secret of the Iroquois' residential fortresses in the next chapter? I will reveal the most closely guarded secret: how hundreds of people lived in one building and did not freeze. If the tepee was a marvel of mobile engineering, the Iroquois longhouse, or Haudenosaunee, was a monumental achievement in communal housing. These massive structures, reaching tens of meters in length, were veritable villages under one roof, and their design was perfectly suited to the harsh winters of the Northeast. The secret to their warmth lay in two factors: scale and collectivism. The longhouse itself was a sturdy frame of curved logs covered with large sheets of bark. This bark was a surprisingly effective insulator, especially when laid in several layers. In winter, a thick layer of snow accumulated on the roof and walls, serving as additional natural insulation. It covered the house like a blanket, smoothing out sharp temperature changes and protecting it from the biting wind. Inside, the house was divided into compartments, each of which was home to one family. But the key element was the hearths located along the central passageway. These hearths were shared by two families living opposite each other. The heat from these numerous fires rose upward, accumulating under the curved roof. Along the roof, there were openings for smoke to escape, which could be partially covered to keep more warm air inside. But the main source of heat was the people themselves. A single longhouse could house anywhere from a few dozen to 100 or more people. Each of them constantly generated heat. This collective heat was a huge resource. The house was designed to capture and retain every degree of heat. Sleeping platforms were located along the walls, raised above the cold floor. They were lined with thick layers of treated skins and mats, creating warm and cozy nests. These platforms often had two tiers. The lower tier served as a place to sit and work during the day, and the upper tier was for sleeping. The space under the lower platforms was used for storage, which also created an additional barrier between the living area and the cold ground. What if I told you that everything you believed about snow was wrong? We are used to thinking of snow as a symbol of cold. But for many indigenous peoples, especially in the subarctic and the northern plains, snow was the best building material and the most effective insulator available. The secret lay in physics. Freshly fallen snow is 90–95% air, trapped in myriad tiny ice crystals. This trapped air is one of the best insulators in the world. Subarctic peoples such as the Cree and Athabascan took full advantage of this property. One of the most effective winter dwellings was the semi-dugout, or pit house. It was not just a shelter built on the surface, but a dwelling dug into the ground. By digging a living space a meter or 1.5 meters below ground level, people immediately solved several problems. First, they were below the level of soil freezing. The temperature of the earth at this depth is always stable and stays above zero, even when it is freezing on the surface. This provided a constant, albeit low, source of heat. Second, the walls that went into the ground were completely protected from the wind. This eliminated the main factor in heat loss. The above-ground part of the dwelling, usually a conical or domed roof, was the only part exposed to the elements. And this is where snow came into play. Winter dwellings, whether dugout houses or above-ground wigwams, were specifically designed to be covered with snow. The snow drifts that accumulated against the walls and on the roof became a thick, wind-proof insulating layer. Residents often helped this process along by lining the base of their dwellings with blocks of snow. This snow barrier completely blocked any drafts and kept the heat inside. But how do you choose the right location for such a house? In the next chapter, we will learn that the location of the village was no less important than the construction of the walls. The choice of location for a winter camp was not a matter of chance, but rather a precise science. A mistaken location could cost the community enormous effort in gathering fuel, or, in the worst case, lead to tragedy. The main criterion for choosing a location was protection from the prevailing winter winds. On the Great Plains, where there are no natural barriers, the winter winds blowing from the north are devastating. They not only bring freezing cold, but also move huge masses of snow. Therefore, the Lakota or Cheyenne communities never set up their winter camp on open high ground.
We have to get to the valley. The camp won't survive the night up here.
Signal the others. Let's move.
The ideal location was a deep, wooded river valley. The slopes of the valley served as a natural wall that deflected the main wind flow, carrying it high above the camp. The trees and shrubs in the river floodplain further dispersed the gusts, creating a zone of relative calm. The location near the river also provided access to water, although in winter it was necessary to break through the ice to get it. But more importantly, river valleys often had willow and other shrubs that could be used for small household needs, and in extreme cases, as fuel. In the forested regions of the Northeast, where the Iroquois lived, villages were also wisely located. They were often built on small hills or plateaus, but always with the windrows in mind. The settlement was surrounded by a protective palisade, which served not only for defense but also as a powerful windbreak. The longhouses inside the palisade were positioned with their ends facing the prevailing wind direction. In this way, the wind hit the narrow part of the building rather than its long, wide wall, which significantly reduced heat loss and wind load. In subarctic regions, groups of nomads chose dense spruce forests for their winter camps. The dense crowns of coniferous trees held the snow and created a relatively wind-protected space under their branches. The layer of snow on the branches also served as an additional insulator. The inhabitants of the Arctic and subarctic understood that snowdrifts were not a hindrance, but a resource. They positioned their dwellings so that the leeward side would accumulate as much snow as possible. This snowdrift became a natural extension of the wall, insulating and strengthening it. Want to know a secret that will change your perception of clothing? When you cannot rely on an external source of heat, your own body becomes the only generator, and the task is to prevent that heat from escaping. Indigenous peoples perfected the art of personal insulation, turning their clothing into a portable, perfectly fitted dwelling. The basis of this art was the principle of layering. No one wore a single thick and heavy garment. Heat was retained thanks to several layers of light but functional clothing, between which air pockets were created. It was this still air in the layers that was the main insulator. The inner layer, next to the body, was often made of softly processed suede. It had to be comfortable and wick moisture away from the body. If sweat remained on the skin, it would quickly cool down and could lead to hypothermia. The middle layer was the main insulator. Fur or thick woven fabrics were used here. It is important to note that fur parts were often worn with the fur on the inside so that it would trap the warm air coming from the body and create a warm, fluffy layer. The top layer was windproof. This was the most important part. It was usually a tightly sewn cape or parka made of well-treated, windproof leather. Its task was to stop the wind from blowing the warm air out of the lower layers. The design of the clothing was thought out to the smallest detail. For example, the peoples of the subarctic and plains commonly wore separate leggings attached to the belt and a loincloth. This provided complete freedom of movement and allowed for heat exchange regulation. Footwear was a separate work of art. Moccasins were sewn to fit the foot exactly. In winter, they were made tall and worn with several layers of socks made of soft, dry grass or fur inserts. Dry grass was an excellent insulator and absorbent, absorbing moisture and keeping the feet dry. Night was the most vulnerable time. As activity slowed, the body produced less heat and the cold became more insistent. Keeping warm during sleep was a collective task, and the solution was built into the very architecture of the dwellings and the social structure. No one slept alone on the cold floor. In the longhouses of the Iroquois, as already mentioned, sleeping places were raised on platforms. This simple elevation of 30-50 centimeters above ground level already removed sleepers from the zone of the coldest air, which accumulated below. The platforms themselves were not just bare boards. A thick mattress of several layers was laid on them. First came woven mats made of reeds or corn leaves, which created a springy and breathable base. Then thick, heavy processed skins were laid on top. These skins served as both a mattress and a collective blanket. Families slept huddled close together. The warmth of their bodies accumulated under the common covering, creating a warm microclimate. Younger family members or guests slept in the center, surrounded by the warmth of others. In the teepees of the Great Plains, sleeping places were located around the perimeter, near the inner lining of the ozone. This was the warmest place, protected from drafts and receiving reflected heat from the central hearth. Sleeping places also consisted of many layers. First, a layer of dry grass or branches was laid on the ground to create a barrier from the cold earth. Heavy hides were spread on top of them. People slept together, using the same principles of collective warmth as in longhouses. The clothes they wore during the day often served as nightwear, especially in severe frosts. Only the outer windproof layer was removed. The remaining layers helped to retain body heat even during sleep. The concept of survival without wood was not absolute, but in many regions, especially the Great Plains, wood was incredibly scarce. The endless prairies were a sea of grass, where trees grew only in river valleys. Using this precious wood for heating would have been an unthinkable waste. The answer to this challenge was to use another widely available resource. This was the dried, compressed dung of the large herbivores that inhabited the plains. Known as pigea by the Lakota tribes, this material was the ideal fuel in a treeless environment. Collecting this fuel was an important task, which was mainly done by women. During the warm and dry months, they gathered the dried patties, stored them in special bags or baskets, and brought them to the camp. Each family had its own supply of this fuel, stored near the tepee. This material had unique properties. When dried, it was very light and dense. It did not burn as hot as wood, but very slowly, evenly, and gave off a steady, long-lasting heat. This was exactly what was needed for a small, efficient hearth. The smoke from this fuel had a distinctive, but not pungent, grassy smell. It was much less noticeable than smoke from wood, which in some situations could be a tactical advantage. The use of this fuel required a specific hearth design. A small depression was dug in the center of the tepee. This allowed the fire to burn below floor level, making it safer and reducing drafts. This small, smoldering fire was the center of life in the tepee. Clothes were dried and food was cooked around it. The heat from it was not scorching, but gentle, and it was constantly maintained throughout the day and night. In wooded areas, of course, firewood was used, but here too the principle of efficiency applied. No one cut down living, green trees. Only dead wood was collected, dead, fallen trunks and branches. We have already discussed the outer shell of dwellings, but the interior finishing played an equally important role in retaining heat. Inside any dwelling, be it a tepee, wigwam, or longhouse, there was a whole system designed to block drafts and create comfortable microzones. Even well-insulated walls remained the coldest part of the dwelling. To cut off this cold from the living space, interior walls were often hung with curtains. In Iroquois longhouses, these were thick woven mats made of reeds or corn fibers. These mats were hung along the sleeping platforms, creating a kind of room within a room. They blocked the convection currents of cold air coming from the walls and prevented the heat from the body and the hearth from escaping outside. In the tepee, this function was partly performed by the ozon, or inner lining. But in addition to this, the space near the walls where people sat was also often decorated and insulated. Backrests were used, a kind of chair made of willow twigs, covered with processed skins. These supports allowed people to sit comfortably, leaning back without touching the cold lining. This was important for long winter evenings when people spent a lot of time in their homes, doing crafts or telling stories. The floor was also the subject of close attention. No one walked or sat on the bare ground. The entire floor surface, except for the area around the hearth, was covered with multiple layers of insulation. First, a layer of dry grass, spruce branches, or willow branches could be laid on the ground. This layer created an air cushion and drainage. Woven mats were laid on top of it, followed by heavy, thick skins. Walking on such a floor was warm and soft. This multi-layered structure prevented cold and moisture from rising from the ground. In addition, the floor in the tepee had a slight slope toward the center, which also helped to combat drafts. Even the most insulated dwelling and the warmest clothing are useless if a person does not have an internal source of heat. That source was food. The winter diet of indigenous peoples was not just a way to satisfy hunger, but a carefully thought-out strategy to fuel the body with high-calorie food. In winter, the body expends a tremendous amount of energy just to maintain its core temperature. Therefore, the diet had to be rich in fats and proteins. Carbohydrates were important, but it was fats that provided the maximum amount of energy per unit of weight and burned slowly. In many cultures, the basis of the winter diet was concentrated, dried foods prepared during the warm season. In the Great Plains, this was the famous pemmican. It is not just dried meat, but a real energy bomb. To make it, sun-dried meat was ground into powder. This powder was then mixed with an equal amount of melted fat. Dried berries were often added to the mixture for flavor and vitamins. The resulting mixture was incredibly nutritious and could be stored for years. A small piece of pemmican could sustain a person's strength throughout a whole day of hard physical labor in the cold. It could be eaten dry or dissolved in hot water to make a nutritious soup. For the farming peoples of the Northeast, the basis of their diet was the three sisters: corn, beans, and squash. But here too, fat played a key role. Corn porridge was eaten with large amounts of fat or nut paste. The fishing peoples of the subarctic and northwest coast harvested huge quantities of fish. It was dried, smoked, and fermented. Fatty fish were especially valuable as they provided not only protein, but also necessary fuel. We can see that the survival of the indigenous peoples of North America in winter was based not on fighting nature, but on deep harmony with it. They did not try to defeat the cold with brute force, but used their intelligence, observation skills, and collective experience accumulated over millennia. Their technologies are not machines, but ideas. The idea of using snow as insulation. The idea of building a home not on the ground, but in the ground. The idea of valuing a small fire over a large one. The idea that clothing is as much a home as a tepee, and that the warmth of community is more important than the warmth of a fire. What other topics from the lives of the indigenous peoples of North America or other ancient cultures would you like to see on our channel? Share your ideas in the comments, and don't forget to subscribe so you don't miss our next episodes, where we will continue to explore the amazing secrets of the past.